Alright guys, moving on to number 17. Number 17 is saying select the false statement below. Okay, so I've gone ahead and written out all the equations, so we're going to go through them and see what's the problem with these. Okay. So first things first. So we're looking for a false statement, right? So we have lead 2 plus iodine making lead iodine. Okay. So the first thing it's saying is it's a precipitation reaction. Well, is that true? Remember, a precipitation reaction is an aqueous plus an aqueous making a solid plus probably like a liquid or something. That doesn't matter. We really just need aqueous plus aqueous making solid. Aqueous plus aqueous making solid. So it's good. It is a precipitation reaction. But it's not a redox reaction. Well, if you go ahead and look at this, remember our redox reaction, for something that has a charge, that's what the oxidation number is. So if my lead has a 2 plus, then my lead here is a 2 plus, my iodine is a minus, and then if I go into this compound, my iodine is still a minus, and my lead is a 2 plus. So it didn't change. Or minus 1, it didn't change. It stayed the same, so it's not a redox reaction. So that's true. Remember, even though it's lead by itself, it's not 0 because it has a charge. If it would have just been PB, then it would have been 0. Okay, but since it has a charge, we use the charge. So number 1 is good. Now we're looking at number 2. CH4 plus O2 making CO2 plus H2O. Is it a combustion reaction? Well, this is methane, CH4. Remember, our combustion reactions are some sort of hydrocarbon plus oxygen making CO2 and water. So it's definitely a combustion reaction. Next up is saying, is a redox reaction? Well, without having to go through all these numbers, I see that I have O2 here by itself, right? So that's going to be 0, right? This doesn't have a charge. It's how oxygen is found in nature. O2, that's 0. And then I see here that I have oxygen in a compound. So it's not going to be 0. So if I know it's 0 here and it's not going to be 0 here, it definitely changed. It's definitely a redox reaction. So this one's also right. So I'm not actually going to go ahead and calculate this out, but you can tell that it is going to be some sort of number that isn't 0. Number 3 is saying calcium solid plus fluorine gas makes calcium fluoride. It's a precipitation reaction and a redox reaction. Well, we do get a solid, but it's not coming from two aqueous things. So this is not a precipitation reaction. That's a precipitation reaction. This is not. So that's already our answer. Let's look at the second one. And is a redox reaction? Well, we have calcium and fluorine gas, calcium and fluorine gas. They don't have they don't have charges, so these are both 0. Then they're in a compound, so here's going to be minus 1, here's going to be plus 2, 0, minus 1. Or I'm sorry, 0. So 0 going to plus 2, 0 going to minus 1, definitely changed. That's definitely a redox reaction. So the second part was right, but not the first part. So let's go ahead and look at the other ones. HNO3 is an acid-base reaction, but is not a redox reaction. Okay. So is it an acid-base reaction? We have an HNO3. So this H is going to go with that OH, making water, and then the K with the NO3 is going to go ahead and make this KNO3. So someone donated an H, someone gained an H. We're talking about an acid base, so that's good. And then, but is not a redox reaction. Well, if we go ahead and look at the redox numbers here, we know oxygen is minus 2, hydrogen is plus 1, so to make this whole thing equal 0, remember it's going to be minus 2 times 3, minus 6, plus 1 is minus 5, so to balance that out, this nitrogen needs to be plus 5. Okay? Now if I look here, my oxygen is minus 2, my potassium is plus 1, and my hydrogen is plus 1. And now if we see if anything changed, well, hydrogen is still plus 1, oxygen is minus 2, K is still plus 1, N is still plus 5, and O is still minus 2. So if you look, nothing changed. So we are not a redox reaction, so number 4 is correct. Number 5. H2SO4 plus barium hydroxide making water and barium sulfate is a precipitation reaction. Aqueous plus aqueous making a solid, definitely a precipitation reaction. This is a liquid, doesn't really matter. You're usually going to get water as a byproduct. That's not a problem. And now let's finally ask me, is it an acid base? Well, I have 2 H's, I have 2 OH's, and I made 2 waters. And then my SO4 and my barium made that barium sulfate. So yep, somebody lost an H, someone gained an H. This is correct. So our answer choice here, well, the one that's incorrect is answer choice number 3, and that is number 17.
The Teaching Center, UF's Learning Resource Center.